All right, so we've gotten pretty good at making our Python programs talk, right? We've been using print to get them to say all sorts of things. But now it's time to teach them how to listen. Today, we're going to dive into the input function. And trust me, this is the tool that's going to completely change the game, turning your code from a simple monologue into a real two-way dialogue. So here's our game plan. First, we'll look at how to shift our code from just talking at the user to actually having a conversation. Then we'll peek under the hood to see how a program really listens. After that, and this is super important, we'll learn how to catch the information the user gives us and actually use it. This will bring us to a really core concept, the difference between static, hard-coded stuff and truly dynamic code. And finally, we'll tie it all together and trace a program line by line to see it all in action.
You know, up to this point, our programs have basically been actors on a stage. They deliver their lines using print, they can tell you things, they can announce stuff, but it's always been a one-way street. They're great at talking, but they've been totally deaf to us, the audience. Well, that ends today. It's time to give them some ears.
The easiest way to think about it is this. Print is your program shouting through a megaphone. It's all about pushing information out. Input, on the other hand, is your program cupping its ear and leaning in, waiting for you to say something. It's all about bringing information in. And that simple switch, from talking to listening, that's the secret sauce behind every interactive app you've ever used. And believe me, this isn't some abstract programming idea. You use the result of the input function all day, every day. Seriously, every time you log into a website, that's you providing input. When you type a search into Google or YouTube, that's input. That prompt you're crafting for ChatGPT, you got it. That's input too. This function is pretty much the invisible engine that makes the entire interactive world go round. Okay, so we get the idea of what input does, but how does it actually work? You know, what's really happening inside the computer when your code asks for information? Let's pull back the curtain a little and check out the step-by-step mechanics. So at its heart, the input function is like a little three-step dance. First, it shows a message. We call that a prompt, to let the user know what kind of info you're looking for. Second, and this is the really wild part, it just pauses. The whole program comes to a screeching halt. And third, it just waits. It sits there patiently until the user types something in and hits the Enter key. Only then does the show go on. Let's walk through that whole journey. Okay, so your program gets to the input line. Step 1, it displays your prompt on the screen. Step 2, boom, silence. The entire program is just frozen in time, waiting for you. Step 3, you, the user, start typing. The program is still waiting. Step 4, you hit Enter. That's the signal. That's the go-ahead. Step 5, the program instantly wakes up, grabs everything you typed, and sends it back to your code as a piece of text. Okay, so this is great. The user said something, and that message was sent back to our code. But that brings up a really, really important question. What happens now? We've got this piece of info, but what do we do with it? How do we hold on to it and make it useful? Right? I mean, think about it. The program successfully got some data from the outside world, but if we don't tell it exactly what to do next, where does that data go? Does it just, disappear into thin air? Well, unfortunately, yes. If you just call the input function all by itself without telling the program what to do with the answer, it's basically like someone handing you a winning lottery ticket and you immediately throwing it away. The information arrives, it exists for a split second, and then it's gone. Poof, totally useless. But here's the beautiful, simple solution, and it uses a tool we already know and love, variables. By using that equals sign, we're giving Python a very specific command. We're saying, hey Python, go run this input function, wait for the user to answer, and whatever they give you back, I want you to catch it and store it in a box labeled name. And once we have that value tucked away safely in a variable, oh man, we can do anything with it. We can print it right back to the user. We can combine it with other text to make custom messages. We just took the user's input, captured it, and used it to continue the conversation. Our program isn't just talking anymore, it's actually interacting. Now, this ability to get info from a user isn't just some neat little party trick. It's a doorway to understanding one of the most fundamental ideas in all of programming, the difference between hard-coded and dynamic code. This is what separates a boring, static program from one that feels smart and alive. This quote really hits the nail on the head when it comes to hard-coded values. A hard-coded value is basically set in stone. It's written right there in the code. The only way for it to change is for you, the programmer, to go back into the file and literally type something new. It's rigid, it's predictable, and it's the total opposite of being interactive. Let's really break it down. A hard-coded value, like saying country equals Germany, is known before the program even starts. It's a fact. A dynamic value, on the other hand, is a question mark. We create a variable called name, but we have absolutely no idea what's going to be in it until the program is running and the user tells us. That bit of mystery, that unknown, is exactly what makes our code feel dynamic. Okay, we've covered a lot of good stuff. We've talked about speaking with print, listening with input, and storing info with variables. So now it's time to see how all these pieces click together. We're going to play the role of the Python interpreter and trace a program's journey, one line at a time. Okay, here's our little script. It's short, but it's got everything we've been talking about. So let's put on our official Python interpreter hats and run this code step by step. We're going to keep an eye on two things: what's happening in the computer's memory and what the user is seeing on their screen. All right, first up, line 1, x equals a. The interpreter sees this and gets to work. It carves out a little spot in memory, puts a label on it that says x, and then it drops the letter a inside that box. Right now, the user sees absolutely nothing. This was all backstage work. Now for line 2, print x. The interpreter gets the order to print whatever is inside the x variable. So it goes to memory, finds the box labeled x, looks inside, and finds the letter a. It then puts a copy of that a onto the output screen. And just like that, the letter A finally appears. Line 3 starts with a hash symbol or a pound sign. The interpreter sees that and immediately knows, oh, this is a comment. It's just a note for a human programmer. It's not an instruction for me, the computer. So it just skips the whole line and moves on. Nothing changes anywhere. And here we go, the main event. Line 4, the interpreter sees y equals input end parentheses. First, it deals with the right side of the equals sign. It runs the input function. That makes the words enter a value pop up on the screen. And then the program freezes. It's waiting. Let's imagine the user types the letter B and hits enter. That B gets sent back from the input function. Now the interpreter can finish the job. It creates a brand new box in memory, labels it Y, and stores that B right inside it. And for the grand finale, print Y. Just like before, the interpreter gets the command to print what's in a variable. It looks in its memory for the box labeled Y, finds the value B that the user just gave us, and displays it on the screen. And there you have it, a full interactive round trip. Information went out to the user, and new information came back in. So let's just quickly recap the big ideas. Print function is your program's mouth. It's for talking. Input function is your program's ears. It's for listening. To make listening useful, you absolutely need variables to catch and remember what was said. And putting it all together is what makes your code feel alive and dynamic, instead of static and boring. You've just unlocked a genuine superpower for your code. You've given it the ability to listen and respond. This is the foundation for everything, from a simple calculator to a complex video game to artificial intelligence. So really, the only question left is, now that your code can have a conversation, what are you going to build with it?